Okay, today is the first lesson in the Common Core Learning for the Common Core Learning Standard 8G1, which is the first geometry standard, and it has to do with transformations. We're going to study 4 transformations: translations, reflections, rotations, and dilations, in that order. And so we're going to talk about translations today, but before we talk about that, let's talk about some vocabulary terms. So actually, I'm going to put it on a... and on this page we have all the notation that has to do with lines, okay, or line segments or rays. So the first notation is how we label this. This is called a line segment, so I would read this notation here as line segment. Okay, and a line segment has 2 endpoints. And it looks like this, so I'd have A and B, or I could also have B and A. Both of those are the same thing. Okay, the next notation would be ray. A ray. Give myself some space here. So this would be ray A B. So that's how you would read that. A ray has 1 endpoint. And you can see the endpoint because it's not underneath the arrowhead. So there's an arrowhead here that's on top of the B. So whatever letter the arrowhead is on top of would be the point at which the line goes off, the ray goes off into infinity. So this would be B right here, and this would be A. Okay, that's different from this ray, because this ray is actually, you can rename this ray as ray BA, but the line segment, the arrowhead above the A. So another way to write this would be B and then A, like that. Okay, and then finally we have line. Okay, a line has no endpoints. It goes off infinitely in both directions. Okay, and the way that we would draw that we would draw it like this, with A and another point here, B. Okay. Now this fifth notation, the capital letters A, B without any line on top of it, actually refers to the measure of a line segment. So this means the measure of line segment AB. Okay, or another way, I can not write the words line segment, I can just write the measure of AB with a line over it. Okay, so when you don't have any of the geometric notation on top of the capital letters, that just means the measure of AB. There's 2 other ways to name a line. Sometimes we name a line with the 2 points that are specified on the line. So okay, so I have 2 lines here, and I have a line segment. I can call this line GH, this first line. I can name it GH if it has 2 points that are specified on the line. But in the second line, the line right below it, there aren't 2 points specified. So I can actually call that, what we do is we write a lowercase cursive letter to indicate that line. So we could write, often the lowercase L is used, lowercase cursive L, but you can use M or N. You know, Q sometimes is used, but not that frequently. Sometimes we use a subscript, so we'll say, if you're given 2 lines that have no point specified on them, so let's say you're given that one and you're also given this one right here, we'll call one L1, L sub 1, and L sub 2, just to indicate that they're separate. Okay, so again, if there's no points that are specified on, like this line right here has 2 points, G and H specified, but L1 and L2 do not have those points specified, so we would name it with a lowercase cursive letter. Okay, angle notation, so there's two ways to notate this angle right here. And if there's 3 points, so remember that an angle is two rays. So the definition of an angle are two rays that share a common endpoint. I guess I don't have to write share if I say common, that have a common endpoint. Okay, so in this case I have ray BC. They also have ray BA. And clearly they share the endpoint of B. Okay, so this angle right here is made up of these two rays that share the endpoint of B. Okay, there's two ways that are used to name angles. I can either name them in order. If there are 3 points specified, then I can name them in order of the points. So I can name it, and I use this little, it looks like half of a part of a triangle. Usually this line right here is parallel to the bottom of the page or parallel to the ground. So I can name it A, B, C. So that's, I want to name it in order, the order that I would read them in. Okay, or I could also label it C, B, A. So using the C as the first one there. But notice I cannot name it B, A, C. BAC would start here, go here, and then go here. So actually I'd have to draw a line here, and this would be angle BAC right there. Okay, so I cannot name it that. I can name it angle ABC and angle CBA. Okay, so this little geometric figure right here is read as angle. So I can name it AABC. So that would be the third one. Or I can start with C and name it CBA. The third way I can name it is just by naming it with the vertex. So if A and C are not specified, or even if they are, it's a shorter way to name it. I can name it angle B, and that's pretty common. So you can name it with the vertex, okay, or the shared endpoint of the two rays that make up the angle. Now, this is a geometric object here, right? This is the labeling of an angle. If I want to talk about the measure of an angle, which would either be in degrees or a unit called radians, which you may or may not have heard before, you hear that frequently in either in geometry, but definitely by Algebra 2, you hear the word radian. So there's two ways to measure a degree. There's two ways to measure an angle. You can use a degree or a radian. Okay, in 8th grade we really talk about degrees, but when you get to high school you're going to talk about radians. And if we're talking about the measurement of it, so how wide this is, the measurement of an angle is really the space between the two rays that make it up. So I would use notation that says, I'd put a little m here, the measure of angle B is how many degrees are in this angle right here, or later on you'll talk about how many radians are in an angle. So this means measurement. It's a measure of an angle. And again, you could have written the measure of angle CBA as well as the measure of angle ABC. Okay, and they're actually going to be congruent to each other. Actually, they're going to be equal to each other, right? Measures are equal. Okay, figures are congruent. So marking line segments congruent is another piece of notation that we have. If I want to say that the length of actually I should have the lines up here, of AB is equal to the length of B line segment BC, then what I can do is I can typically mark it with a little dash right here. And I use the same amount of dashes or hash marks in order to indicate that those two line segments, both AB and BC, are equal to each other. Sometimes you'll use one, sometimes you can use two to indicate that. So if I want to say that line segment, that the measure of DE is equal to the measure of EF, remember, that's also saying that the geometric figure of the line segment is congruent to the geometric figure of the line right here, the other line segment. Okay, and we haven't talked about the difference between the equal sign here and the congruent symbol right here. But basically, the difference is that when you have the measurement is some sort of number, okay, some sort of number with a unit on it. So I can say, well, this is maybe an inch long, the other one's an inch long. I say that those two numbers are equal. But remember, DE is the measurement, whereas DE with a line over it is the line segment. Okay, so this is a geometric object. That's a geometric object. Whereas this is a measurement. So it's like a number. Alright, so measurements can be equal to each other, but geometric objects have to be congruent. And the symbol for congruency is the equal sign with a little squiggly line above it. So if I want to say that the measure of line segment DE is equal to the measure of line segment EF, then I could put, but I want to make sure that I know that this measure does not equal AB, for instance. So I don't want to just use one hashtag. I want to maybe use 2 or some other number different than 1. I can put 2 hashtags here, not hashtags, hashes, hash marks, and I can put 2 there to indicate that these two are equal to each other, but they are not equal to this one. Okay? When I mark angles congruent, the same thing. So if I have an angle, let's label this angle A. We'll label that B. If I want to say, so I would either say that angle A is congruent to angle B, because geometric objects are congruent to each other. Or I could say the measure of angle A is equal to the measure of angle B. Okay, these ideas are very similar, but they're not the same. All right. If I wanted to say that using notation here, what you do is you draw a little rounded piece like that inside the angle, inside of both angles, and you put a little hash line there or hash line there. Okay, and you use the same number of hash marks in order to indicate that those two angles have equal measures, or those two angles are congruent. Okay, similarly here, let's say that I have these two angles. Let's put it in a different color here. Let's say I have A, B, you know, let's label it with something other than A, B. Let's say that I have C, D, and E, and F here. So I could say that the measure of angle CDE is equal to the measure of angle EDF. If I wanted to indicate that on the drawing itself, I'd put this little rounded mark here. And I'm going to use 2 hash lines here because I want to make sure that they're not going to be confused. They're on the same page as angle A and angle B above it. I don't want them to be confused with being equal to the measures of those angles. Okay, and if you didn't want to use the equality symbol, another way of saying that, you could say that angle CDE is congruent to angle EDF. Okay, notice I cannot call this angle, well, I could call that angle D, but angle D is not the same thing as angle CDE. Angle D is this large angle right here. Okay, if I split this into 2 congruent parts, then this part right here is not angle D, it's angle CDE, because this whole thing is angle D. Okay, marking 2 line segments parallel. So when we mark 2 line segments parallel, we make these little arrowheads on them. Okay, sometimes we use 2, sometimes we can use 3. like this. I think it's more typical to use two of them, and then I would write, so on the drawing I'd make these little marks right here, and that would mean that, let's say that this was L1 and L2, and I want to say that L1 is parallel, that's another notation we use, is straight lines, is parallel to L2. Okay, this is what I would write in a sentence, and if I wanted to show that on the drawing, I'd use these two little symbols right there. Okay, and marking line segments perpendicular, so let's say that L1 is perpendicular to L2. I put this little part of a square in the corner of the, or inside the angle. All right, so if L1, and the way I would write it on a paper is I'd say L1 is perpendicular. I'd make this little upside down T is perpendicular to L2. Right? So if I were writing it in a sentence, I would use that notation. If I were marking it on a drawing, I'd use this notation. Okay, so let's get down to talking about translations. So let's say that I wanted to translate this quadrilateral, and I want to name this quadrilateral A, B, C, D. Okay, I can either start at A, 1, 2, 3, 4, or I could name it starting at B. So this is the same as quadrilateral B, C. Let's see, it would go B, C, D, A. Okay, or I could have started at C, so it could be C, D, A, B. Right, or I could have started it at D. So these are all the same quadrilateral. A quadrilateral that would not be the same is if I didn't name the vertices in order. So let's say I went A, C, D, B. Well, that would be this quadrilateral, A, C, D, B. Actually, so the quadrilateral would be sort of a concave quadrilateral there. Okay, so if you want to make to name a quadrilateral, you have to name the vertices in order. You can start at any vertex. It's pretty typical to start at the one that's the first number in alphabetically, or the first letter alphabetically. It's typical to start with that, and then name them going around alphabetically. But you can really technically start at any of the vertices, and as long as you go in order, you can name the same quadrilateral. So let's say that I wanted to translate this quadrilateral A, B, C, D, and I wanted to translate it 6 units to the left. So 6 left and 2 down. Okay, so 6 units to the left would be 1, 2, 3, 4, 5, 6 here, and 2 down. Whoops. So 1, 2, 3, 4, 5, 6 here, and 2 down would be here. Okay, and I would label that A prime. All right, we use prime notation when it's some sort of transformation from the vertex A. So this is a copy of A, but it's in a different location, so I would name it A prime. I would do the same thing with B, so I'd move it 6 left, 1, 2, 3, 4, 5, 6, and 2 down, so 1, 2. So that's B prime. 1, 2, 3, 4, 5, 6, 1, 2. That's C prime. And then 1, 2, 3, 4, 5, 6, 1, 2 is D prime. And I would connect all of these parts right here, and that would be my new quadrilateral. Now notice the coordinates of these new figures. A prime, the old A prime was at 1, 4. Okay, or sorry, the old A was at 1, 4, and now A prime is at -5, 2. Okay, let's just look at A and B for a minute. So B was at 4, 2, and B prime was at is at -2, 0. So if we think about what happened with the coordinates, it's similar to what we asked you to do with the transcription. So we asked you to go 6 to the left. Now, to the left changes the x coordinate. So going to the left means that you are changing the x coordinate. So whatever the x coordinate was before, you have to take that x coordinate and subtract, because going to the left means that you are subtracting, you're making it smaller, just like on a number line. If you go to the left, you're making it smaller. So you have 1 minus 6. Okay, that's your new x coordinate. And if you go 2 down, you take your y coordinate and you subtract 2 from it. So your new coordinates would be 1 minus 6 is negative 5, and 4 minus 2 is 2. Okay? So your b coordinate, if we look at the b vertex rather, we did 4 to get the new x coordinate for b prime. We did 4 minus 6, which is negative 2. Okay? And we did 2 minus 2, which is 0. Right? So the rule here was that if you went 6 down and 6 left and 2 down, what you did in general to your x coordinate, so your old x, y coordinates would become x minus 6 comma y minus 2. So this is a notation that shows you, you can use a little arrow to indicate that that's how we transcribe. This notation shows you how to write, it describes a translation in terms of a coordinate pair. Okay, so if I applied those changes to the c coordinate, so c is at 6, let's see, the c is at 6, 4. So to get c prime, I could apply this rule, so it would be 6 minus 6, which would be 0, and 4 minus 2, which would be 2. And if we look, our c prime is at 0, positive 2. Same with our d. If I had a d that was, our original d is at 4, 5. If I subtracted, so d prime would be at 4 minus 6 is negative 2, and 5 minus 2 is positive 3. So it should be at negative 2, 3, which it is. Okay? So the notation is, let me just rewrite it again so make sure you have it in your notes. X, y goes to, okay, that little arrow indicates what it changes into, x minus 6 comma y minus 2. Okay? Let's say that I were translating this triangle ABC, so this notation would be triangle ABC. Okay, if I were translating that, let's say 2 up, and let's go, we have to go to the left here, so 4 left and 2 up. Okay, so 4 left, left is a horizontal change, so all of your, so if we had x, y coordinates originally, what would end up happening is that, so let's try it with our a, so we go 4 left, 1, 2, 3, 4, and we go 2 up, which is 1, 2, right here, there's our a prime. Our b would be 1, 2, 3, 4, 2. And our c would be 1, 2, 3, 4, 1, 2. Okay, so that's our c prime, so 4 left and 2 up. Let's just write that over there. That's our c prime, and we connect these points right here. Oops. You can see that those figures are almost identical, but they're in different spots. There's our c prime. Okay, so 4 left and 2 up, you can see the difference. If you wrote down the original a coordinates would be 2, negative 2, and a prime would be negative 2, 0. Okay, so 4 left means that you have to take your x coordinate and subtract 4 from it. 2 up means that you take your old y coordinate and you add 2 to it. Okay, and if you see this change if you look at your the difference between b and b prime. So if b is 3, 3, and we apply the general rule to it, so b prime must be at -1 and 5, and that's where we would find it. That is where we found it. Okay, and C would be the same thing. C was at 9, 2. So C prime must be at, so subtract 4, that would be 5 and 4. So C5, and that would be 5 and 4. Actually, C prime is supposed to be right there. So I made a mistake when I was counting over. So that must be C prime right here. Okay, so let's say that I have this figure, the triangle ABC, and actually I'm going to skip that slide. So let's say that I have these two figures, triangle ABC, and I should have this one labeled as A prime, B prime, and C prime. Use of prime notation is really important because you have to see which one the original is, which would be the ones without the primes in it. So B prime. Okay, so if I asked you what to describe the translation and you were going to do it using coordinates, so your old xy coordinate would become. So let's look at the moves that A made. So this A went down 3 spaces. So down 3, and it went to the right 1, 2, 3, 4, 5. So right 5 and down 3. Okay, so right would be your x change because it's the horizontal change. If we're going to the right 5, that means we're adding 5 to the right coordinate here. So we have x plus 5. And down 3 means that we take the y coordinate and we subtract 3 from it. Okay, so if we were asked to describe the translation, we would use this notation, meaning your old xy coordinates go into x plus 5, comma y minus 3. And one more practice problem. So if I had, let's say that the blue figure is my prime figure, so is my translation. Say I made this translation and you were asked to describe it. Well, your old x, y coordinates would become, now let's look at what's going on here. Between A and A prime, it went up, let's see, up, right? 1, 2, so up 2, and then it went right 1, 2, 3, 4, 5, so right 5, okay? Now we deal with the right 5 first because that's the horizontal change. So your old xy coordinates would become x plus 5, and your old y coordinates would become, up means you add something to the y coordinate, y plus 2. And if we just quickly checked, let's see, your C is at 1, negative 1. So using this system, let's see, C would have to add 5 to the x coordinate and add 2. So negative 1 plus 2 is positive 1. So your C prime should be at 6, 1, which is correct. So you can check yourself. You can check the other vertices too. And that is the last slide. Okay, so that's how we work on translation. So there's 2 ways to describe translations. You can just sort of describe it in this context, up and to the right or down and to the left or any combination of that. Or you can use coordinate notation to describe what happens from the original coordinate going into the new coordinates. So you would use the XY system of describing that, and this little arrow in between to show that you're transforming it.